welcome back. We're going to keep going on our homework 8.3. Let's do it. Now this is called a flow chart because it has boxes and arrows. So as we take a look, same kind of setup though. This is the first thing we were given, and there it is. And so we want to write given. This is the next thing we were given, so we want to write given. Okay. Now, we are trying to prove that, so that better be last, but we can't write proof. We got to tell us why. Okay, so I go to the end here, and yep, they wrote what we're trying to prove, and I can't write prove there. That's my end goal. But it does look like I'm trying to prove that the triangle on the top is equal to the triangle on the bottom. And so I'm betting it's one of those evidence spell questions, but I need to make some marks. So let's do it. It says KJ bisects an angle. So you have to define that by the definition of angle bisector. So by the definition of angle bisector, angle 3 has to be equal to angle 4 because they said that this KJ bisected that angle. Okay, so those two angles are equal. Now, they said, and they didn't give a reason, JK is congruent to JK, and it doesn't show up there. So I'm betting that that is shared side. What did my notes say about a shared side? There it is. That's the reflexive property. Okay. So now, I'm looking at my evidence. They also gave me this. JML is congruent to JPK. Let's see. JML. I'm thinking that's a typo. JPK. So I'm thinking this is supposed to be a K. Okay, so I'm thinking that this was supposed to be the angle at M and the angle at P are congruent. All right, so I'm going to put two necklaces. Sorry about that typo. I knew there was a typo. I just couldn't remember where it was. So this spells angle, angle, side, angle, angle, side. Cool. So that's what goes here. Angle, angle, side, triangle congruence. Now, I have to name the top triangle and the bottom one, and I just need to go in that same order. So I could go in this order, JMK. I'm talking about the top triangle, JMK. Now I'm forced to name this bottom one, JPK, because I have to talk about no angle, the second angle, the first angle. JPK, okay? Now, after they know those are equal, they're wanting to talk about this angle happening at angle J. So they say, oh, the angle happening at J, all right, this angle 1, wouldn't that be congruent to this angle 2? That should be a corresponding part, CPCTC. So that's one of the 6 parts after I know they're congruent. Awesome, let's keep going. Now we're on the back. Here it says, given that one segment is equal to another. Getting better. And I marked that up. One segment is equal to this segment. I'm also given AD is congruent to CB. AD, CB, okay. Now, they just said out of nowhere, ACE. I don't see that here. I also know this has to come last. Proof. That's what we're trying to do. Oh, there it is. There it is, but I can't write proof. But if it wasn't there, I would have filled that in. Now, I'm noticing this. So they're saying these are equal. That looks like a shared side, so that's going to be reflexive. And now they're saying I have 3 pieces of 1, 2, 3. Yep, I do have enough evidence to give my triangle congruence statement. Okay, so my evidence spells, okay, most of you got this one right, side, side, side today. And I just need to be consistent in my naming. So I could call it ADC, then I'd have to call it CBA. Okay? And then what comes next after a congruence statement? They picked one of those parts, CPCTC. So what they're saying is, if you know these are congruent, angle 2 is DAC, so the angle happening at A, is supposed to match angle 4, the angle happening at C. And so see, they're both at the same place, so they should be corresponding parts. So I'm just going to add a necklace there. 2 is supposed to equal 4. Well, how are we supposed to know that? You should notice that if those are equal, kind of going backwards, if we know these are equal, see the Z, then we actually know these are parallel. And that's what we've been asked to prove, that they're parallel. So that's called converse. And I got to pick one of these theorems. So that looks like they're on alternate sides and they're interior. So converse AIAT. Awesome. Called converse alternate interior angle theorem. Now last, some of us, not everybody, but most people got a chance to practice a paragraph proof. So let's take a look. It says, given this, okay, and this, prove that. Okay, so given this, so it looks like I got to put everything in here. And then it says the word given again. So I think I'm going to put this first step here. And then I'm also given that C is the midpoint of BD. Okay. So those were my two given statements. And then last, I'm supposed to prove that. So that they actually filled in. Therefore, that's the prove statement because, and we can't put prove, we got to put an answer there. Okay. So anytime we see this symbol, we have to make marks on our grid and we have to go through the two-step process in our notes. The symbol means talk about the two angles, that they're right angles, and then set them equal to each other. So talk about the two angles, so that'd be B and D. Since the definition of perpendicular creates right angles, and angle B and D are right angles, and never mind. I think they're restating that. Yeah. So I think they just put, since the definition of, perpendicular. Sorry about my mistake. Since the definition of perpendicular means they're creating right angles, we know that's what I want there. Angle B and angle D are right angles. Okay. So, from my cheat sheet, it says I want the two angles are right angles, and then I want to set them congruent to each other because all right angles are congruent. So it would follow that angle B has to be congruent to angle D because all right angles are congruent. Now, it's also given that C is the midpoint. So we have to define that. The definition of midpoint would say that the left and the right are equal. So if this is in fact in the middle, then we know this has to equal that. Now it says because of vertical angles, okay, so we have to identify the vertical angles. So that would be angle ACB, that's this angle, would need to be congruent to BECD. Okay. Now they're ready for me to give a triangle congruence statement, and I need a triangle congruence theorem. Okay. So when I look at this, my evidence spells angle, side angle, angle, side angle. So that'd be angle, side angle, triangle, congruence. But I have to name my triangle, so I got to be very careful. I got to name them in the same order. So this one I'm going to put no necklace, a box, and one necklace, ABC. All right, then so the other triangle, I got to go to the same order, EDC. Awesome. Now that they're congruent using CPCTC, I can pick any corresponding angle. So this angle probably has to match that one. This side here has to match that side. So which one do I pick? I got a lot of choices. Well, let's figure out what it was they asked me to prove. They asked me to prove C is the midpoint of AE. So if that's the case, they want me to say that these two are equal. AC is equal to EC. So they really want me to say AC, first and last, is equal to EC, first and last. And I can say that because that is the definition of midpoint. So anytime you see this midpoint, you better talk about defining that word. Thanks for joining us. Good luck on the test.